The most striking thing about a cat's eyes, especially in a dimly lit room, is that otherworldly glow. It's often called eyeshine, and it's caused by a specific anatomical feature called the tapetum lucidum. This is essentially a layer of tissue right behind the retina that acts like a mirror. When light enters the cat's eye, it passes through the retina, where photoreceptor cells try to capture it. The light that gets missed then hits the tapetum lucidum and is reflected straight back through the retina for a second pass. This gives the photoreceptors a second chance to catch every available photon. It's an incredibly efficient system for maximizing vision in low light, effectively amplifying the ambient light. The color of the glow itself, which can be green, blue, or yellow, depends on the minerals that make up that specific cat's tapetum, like zinc and riboflavin. This low-light specialization is a recurring theme in the feline eye. Take the pupil, for instance. A cat's vertical slit pupil isn't just for looks. A study from the University of California, Berkeley, found a strong correlation between vertical slit pupils and ambush predators that are active both day and night and hunt low to the ground. The vertical slit has a huge advantage over a round pupil like ours. It can change area far more dramatically. A cat's pupil can expand by a factor of 135, while a human's only expands by about 15. This gives them a dynamic range that's almost like having built-in sunglasses and military-grade night vision in one. In bright sun, the slit can close to a tiny sliver, protecting the sensitive retina. In the dark, it can open into a huge, near-perfect circle to let in the maximum amount of light. Once that light passes through the pupil, its fate is decided by the retina. The retina is lined with two types of photoreceptor cells, rods and cones. Cones are for seeing color and fine detail, and they work best in bright light. Rods are for detecting motion and seeing in shades of gray, and they're incredibly sensitive to dim light. A human retina is packed with cones, which is why we see a vibrant, high-definition world during the day. A cat's retina is the opposite. It is absolutely dominated by rods, having about 6 to 8 times more of them than we do. This is a direct evolutionary trade-off. They have sacrificed detail and color vibrancy for a supreme ability to detect the slightest flicker of a mouse's tail in near total darkness. This brings us to their color vision. It's a myth that cats are completely colorblind, but their world is much less colorful than ours. Humans are trichromats, meaning we have 3 types of cone cells that are sensitive to red, green, and blue light. Cats are dichromats. They have cones for blue and green-yellow light, but they lack the cone for red. This means their perception of the world is mostly in shades of blue, yellow, and gray. To a cat, a bright red toy doesn't look red. It likely appears as a shade of yellow-green or dark gray, depending on the lighting. They can distinguish blue from yellow, but not red from green. While their vision is blurrier and less colorful than ours, it's superior in other ways. A cat has a wider field of view, about 200 degrees compared to our 180. More importantly, they have excellent binocular vision. This is the area in the center of their vision where the fields from both eyes overlap. This overlap is what creates stereoscopic vision and allows for accurate depth perception. For a predator that needs to calculate the precise distance and trajectory for a leap onto its prey, this is a non-negotiable feature. Their binocular vision is about 140 degrees, which is better than most predators and gives them that critical edge. However, the trade-off for all this low light and motion sensing capability is visual acuity, or sharpness. A cat's vision is estimated to be around 20/100. This means that to see an object with the same clarity that a human can from 100 feet away, a cat needs to be just 20 feet away. They are technically nearsighted. They don't need to read the fine print on a sign from across the street. They need to see the general shape of a bird, and most importantly, the fact that it is moving. Their entire visual system is optimized not for static detail, but for detecting and tracking movement. This is also why they have a higher flicker fusion threshold. They can perceive rapid flashes of light as separate images at a rate that would just look like a continuous glow to us. It contributes to their incredible ability to track fast-moving insects or laser pointer dots that can seem to blur for a human observer.